Good day all of you. Today's gate question is, let an input x of n having discrete time Fourier transform x of e power j omega is equal to 1 minus e power minus j omega plus 2 into e power minus 3j omega be passed through an LTI system. The frequency response of the LTI system is h of e power j omega, that is equal to 1 minus 1 by 2 e power minus j2 omega. The output y of n of the system is, yes, they consider one LTI system. Yes, let the input sequence be x of n, output sequence be y of n, and LTI system impulse response be h of n. So what is y of n? You know what y of n is x of n convolved with h of n. In frequency domain, you can write it as y of e power j omega is equal to, frequency domain, the convolution becomes multiplication. So x of e power j omega into h of e power j omega. Okay, then what it implies? It implies y of e power j omega is equal to, just multiply both x of e power j omega and h of e power j omega, both are given. 1 minus e power minus j omega plus 2 into e power minus j3 omega into h of e power j omega is 1 minus 1 by 2 e power minus j2 omega. If you multiply these two, yes, 1 minus 1 by 2 into e power minus j2 omega for 1. And then for this, it is, the first term is minus e power minus j omega and the second term is minus minus plus half. It is e power minus j omega into e power minus j2 omega. So it will be e power minus j3 omega. Yes, for the third term, the first term is 2 into e power minus j3 omega. And the second term is plus minus minus 2 into 1 by 2 gets cancelled. And e power minus j3 omega into e power minus j2 omega is e power minus j5 omega. So if you solve this, 1 minus this, you'll get 1 minus, first you'll write e power minus j omega term. Then 1 by 2 e power minus j2 omega term. Then here 1 by 2 e power minus j3 omega plus 2 into e power minus j3 omega. If you take e power minus j3 omega common, it becomes 1 by 2 plus 2. So 1 by 2 plus 2 is 5 by 2. Plus 5 by 2 into e power minus j3 omega minus e power minus j5 omega. This is your y of e power j omega. Now, by taking IDFT, inverse discrete Fourier transform on this expression, what you'll get? I'll get y of n. For the first term, one inverse discrete Fourier transform is delta of n minus, for e power minus j omega, the discrete, inverse discrete is minus delta of is n minus 1. And for the third term, it is minus half delta of n minus 2. And for the fourth term, 5 by 2 delta of n minus 3. And for the last term, minus delta of n minus 5. Okay, the inverse of e power j omega is delta of n minus 1. That we used here. Okay. So if you observe the answer and compare the given options, and the given options, yes, yeah, this is the correct answer.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.